Hello, my name is Victor and this is MetalGraph. MetalGraph is a node-based macOS application where you can design and understand metal shaders in real time. The reason I built it is because while I was learning metal and working on metal shaders, even though we have SwiftUI previews, it didn't feel real time. So let me show you a very simple example of what I mean. Usually the way I work with metal shaders in SwiftUI is I have the SwiftUI preview in one side and the metal code on the other. And if I want to tweak something like a color, I want to change this deep blue at the top or something else like a pink. I have to save, wait for it to reload, and then I want to see the result. And that's good, but it's not real time. And I worked in the past with Blender where they have a node-based application, and it's basically amazing. You get to see everything in real time, and you can tweak values and you can connect stuff to another, and it's really good to understand and to and see what you're doing and see the effects of it in real time. So that's what I was trying to make with MetalGraph. In this video, I'm going to give you I'm not sure if it will be quick, but an overview of what MetalGraph can do. And we will go over some examples on how it works. And I will show you why it's useful for me and maybe could be useful for you as well. Let's start with the output node. So MetalGraph was designed to work with SwiftUI. SwiftUI has 3 different modifiers. They are called color effect, distortion effect, and layer effect. You can apply those effects to any view. You can apply them to an image, you can apply them to text, you can apply them to a full C stack, V stack, whatever. But the way you define those functions in Metal, it's very particular, depending on if you're using a color effect or a layer effect or a distortion effect. The signature of the function changes, and the parameters that you get are different. That's why it's very important when you start in MetalGraph to select which kind of shader you're building, so you can choose between the same ones, color effect, layer effect, or distortion effect. This selection will affect which input nodes you can choose from, as well as other things. So let's start with the color effect. The most simple shader you can build is just returning a color. So a color effect function in Metal receives a position for a given pixel, the current pixel. It receives the color for that pixel, and you need to return the new color, whatever that is. You can transform it, you can create a new one. So in this case, we're simply returning white or red or whatever color. Now, the source color will give you the color at the current position. So if I return the source color, what I get to see is the underlying view. So in this case, this is a sample photo, but I built in some different views. So for example, Hello World is a text view. Sample photo is just a photo. And what I'm doing is I am applying the color effect to that image. I'm receiving a pixel color, and I'm just simply returning it as the output. So for the first example, what we are going to build is a simple black and white metal shader function. The simplest way to build a black and white function is simply by returning the same color. It's like building an RGB color out of the same values. So I could split this color into RGB values. We don't need the alpha, and just return whatever the red value is, same value for the green and the blue. So if I output this is what this will do. It will take the current red value for that pixel, let's say it's 0.18, and it will return a color made out of 0.18, 0.18, 0.18, and 1 for the alpha. I can do the same for green and the same for blue. To make this a little bit more interesting, we can add some weights. So let's pick up a float node and a multiply node. So what I'm going to do is I'm going to multiply the red channel by some value, and I'm going to do the same for the green, and the same for the blue. So the green multiplied by this float, and the blue I am going to multiply by this float. And now I'm just simply going to add them all. So I'm gonna add this one to this one, and I am going to add the result to the blue, and that's going to be my output. The interesting thing about this is that now I can tweak these values. So I can drag this to modify the red channel. I can modify the blue channel and the green channel, and just get it to where I want it. And I don't need to wait for it to recompile. Everything is in real time, and it's amazing. So this was a very quick example on color effect. Let's move to distortion effect. I'm going to open one of the built-in examples. This one is called wave. Now on distortion effect, what you receive is the current position, and the function expects you to return a half to, so a new position. You receive, I don't know, a 0, 0, and you tell it where do you want it to put it? Up here, down here. So the way we are creating this sinus function is by getting the current position of the pixel, and over time adding some, like transforming that position using a sinus function. We can move over to the code palette here, and here you get to see what I mean. So my shader receives a position. We don't need those now. But basically it receives a position, and it expects you to return a float 2, which is like a CG point, a new 2-value tuple. And yes, so let's go over the graph and understand this code a little bit. So this is the original position of the node, of the pixel, whatever that pixel is. And what we're doing is we're getting the X value here. If I get the Y value, the axis changes. And I'm dividing it by a float. Doesn't matter, but this is what represents the wavelength. So if I make it very small, we'll get to see more. Yeah. So I'm taking the Y position, dividing it by some value, and adding the time to it. And this is what we are feeding to the sinus function. So if we move back to the code, we'll see that there's a sinus function here, and we are adding the time to the position y divided by the wavelength. Now the output of this function, we are multiplying it by some value again, a float, in this case 10, which represents the amplitude. And I can go, let's make it bigger. And then that's it. The only thing we do is with this combined vec, what we're doing is creating a new vector where the x is 0 and the y is the output of the sinus function over time. So now that we have a new vector, what we're doing is adding it to the original position. This line here comes from the original position, and we're simply adding the result, and that's the output. And now let's see an example for a layer effect. So let me open this lens effect, for example. So the lens effect is a little bit tricky to go over. It's a bit extensive, but just so we can see what's going on, or to better understand what a layer effect does. A layer effect is like a color effect, but it can sample colors in positions that are not just the current position. So in a color effect, we receive the color directly of the current position. In a layer effect, what we receive is the layer itself and the current position if you want it. But the good thing is that we can sample, we can ask, okay, we are in position, I don't know, 100 on 100. And what's the position of the 101 100? So I know the color of the pixel on my right, on my left. I know the color on the position of the 0, 0. That way I can sample that pixel and ask for that color and use it however I want it. But that's very powerful, and that's what allows these kind of effects. Let's go over a simpler one, which can be the chromatic aberration. So what the chromatic aberration example does is, this is the current position of a pixel, and we sample the layer on that position and use, in this case, the green value for the color. Now for the red and the blue, what we do is, before we sample, we shift it. So in the case of the red, we are adding 5, or we can do a bit more, so the layer moves a bit more. We add 5 or 27.79 to my current position. That way what I'm doing is sampling that pixel here, and I'm getting the red channel. And then for the blue, we're moving it the other way. So instead of adding, we are subtracting whatever value. And then we are sampling on that position and getting the blue out of that position. And finally, that's we generate the color by mixing those three together. So that's all I have. This is MetalGraph. You can generate and create many good metal shaders from it. The last thing I want to show you very quickly is that I have a built-in chat, because I kept asking Claude for advice. And I kept asking Claude about how can I do this, or why does this work that way. So you can bring your own key. You can use ChatGPT or OpenAI or Anthropic keys, and you can use the chat. The chat has the context for the current graph and all the nodes. So you can, I don't know, ask questions like, why do we need 3 sample layers? You can also ask like, how could I don't know, how could I do whatever thing? And because it has all the context, it will basically point you to the right direction and tell you, well, you should maybe add this node or remove this node and try this. So I found this very useful, especially when learning. And when I don't understand something, I always go over here and ask. So that's it for me. I really hope you enjoyed it. If you're learning SwiftUI with Metal, I think this is a great tool for you. And that's all. Goodbye.